Hello? Hello? Okay, so if you look at this linear program and you might think to yourself, hey, something looks wrong, then you are absolutely correct. Why is that? Because remember that one of the quirks of linear programming is that you are restricted to positive variables. That is why we always put the non-negativity constraint x sub I, or whatever your variable is greater than 0 for all I at the end of the linear program to make sure that our decision variables only take on positive values. But the thing is, take a look at our decision variables here. x1 is positive. Does this check out? Yes. But x2 is negative and x3 is unrestricted, meaning that it can take on either positive or negative values. These two obviously do not comply with the non-negativity constraint or the non-negativity assumption of linear programming. And if you did not watch this video and you go take the exam and there's a question with negative and unrestricted variables, you don't answer it, you say, haha, trick question. Then you come to me going, Sir, bakit zero ako sa problem na yan? Di ba trick question yan? Then I'm sorry, you are absolutely wrong. Because it might be hard to accept, pero minsan talaga, sometimes, masakit ang katotohanan because the truth hurts. And this is one of the cases where the truth hurts because in this case, it's not a trick question and there actually is a way to linearize that. And that is why you should watch this video. Thank you for listening to that very useless, I think that was a 1-minute introduction. So now, we can go to the actual video. So how do we do this? First, for x sub 1, we can leave it as is, right? Because x sub 1 is already positive. So we can just put, for the sake of putting it here, x sub 1 equals x sub 1. And in our objective function, we can just leave it as is also. Max z equals x sub 1 stays here. Subject to the x sub 1 constraint also stays there, right? Galing natin. Sobra. Let's go management engineer. Next, how about x sub 2? X sub 2 is negative. So how do we represent a negative variable using a positive variable? If that makes sense to you, I hope it does. It made sense in my head. So we can just have x sub 2 is equal to x sub 2 minus, negative x sub 2 minus. So if x sub 2 is negative 3, then what will x sub 2 minus be equal to? That will be equal to 3, which is positive, which will be accepted in the linear program. So we add that here. So since x sub 2 is positive in the objective function here, and x sub 2 is equal to negative x sub 2 minus, we can put that here as a minus x sub 2 minus. And if we want x sub 2 to be less than or equal to 4, how does that translate to this constraint? This means that x sub 2 minus should be, pag-isipan nyo, tama, I hope you got the right answer, greater than or equal to 4. We just flip the inequality and flip the sign. Next, for x sub 3, how do we do this? We split x sub 3 into two components. That would be x sub 3 plus minus x sub 3 minus. So if x sub 3 is equal to negative 10, then what will x sub 3 plus and x sub 3 minus be? X sub 3 plus will be 10 and x sub 3 minus will be 0. X sub 3 plus can also be equal to 15 and x sub 3 minus in this case will be equal to 5. Both are valid given this constraint, not a constraint, definition. And does it matter which one you take? No, because in the objective function, we're just gonna add that as plus x sub 3 plus minus x sub 3 minus. And it doesn't matter which one you use. And we just put this here as x sub 3 plus minus x sub 3 minus is in between, I miss physical classes. Ay nako, ano ba yan? Yo, let's go. Negative 6 and 8. And here, we can just put are variables x sub 1, x sub 2 minus, x sub 3 plus, and x sub 3 minus are greater than or equal to 0 for all I. So now if this appears in the exam, you cannot say, "Sir, trick question." Kasi hindi ito trick question. Thank you. Guess it's recording. Sometimes I forget to click record.